Yeah, we welcome you to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, we are looking at this question. It says, consider the reactions below. So these are the reactions we are having. Okay? And the question says, complete each of the equation above and write the expression for equilibrium constant. So how do you go about this? Let us look at the first one. The first one is between CH3 COOH. This one is, we call it ethanoic acid. It's an organic acid. And what happens? What is the reaction when this one combines with water? Okay. So what happens is that you need to remember that this ethanoic acid is acidic in the presence of water. And if you are going to win in these scenarios, you need to use Bronsted-Lowry's idea. According to Bronsted-Lowry, an acid is a proton donor and a base is a proton acceptor. So if we say this is an acid, what does it do? It donates a proton to water. So water getting a proton becomes that. Now this one is what we call hydronium ion. And when ethanoic acid loses a proton, you need to know here, it's very important, that the proton in ethanoic acid, which is dislodgeable, is this one. Don't become confused with the three. These ones are not dislodgeable. They can't be lost. So that is very important to you as a scientist. So this is the proton which is donated to water. So what happens after that? What remains behind is going to be CH3 COO minus. Yes, that is the equation. Then the question said we write the expression of the equilibrium constant. You need to know that it's the acid which is ionizing. So what we are going to have is going to be called Ka, acid dissociation constant. And like we did with the chemical equilibrium, equilibrium constant or acid dissociation constant is the product of concentration of the products over product of concentration of the reactants. You need to know that square bracket represents concentration. So you're having concentration of hydronium ion into concentration of that ethanoate ion over concentration of CH3 COOH, which is the ethanoic acid, into concentration of water. But there's a catch. The catch is that water, what we present in the equilibrium constant expression are changes, and water almost remains unchanged during this reaction. So there's no change in water. We represent it by 1, no change. So the actual expression for acid dissociation is going to be Ka, which is equal to concentration of hydronium ion into concentration of ethanoate ion over concentration of ethanoic acid. Water, because it has not undergone any change, is not represented. So next time the question comes and it wants you to write the expression of the acid dissociate constant, this is the expression. Water is out. Yeah, so comes this equation. It's between HNO3, which we call nitric acid, plus water. Okay, what do we get as the products? You need to know that it is nitric acid which is the acid. And when it's an acid, so this is the base. And like I always tell you, we use Bronsted-Lowry here. An acid is a proton donor, and the base is a proton acceptor. So what happens here is that this acid will donate a proton here, giving you hydronium ion. And when nitric acid lost a proton, what remains behind is NO3 minus. Okay, so that is that. So the question is, what is the expression of the equilibrium constant? Okay, this one being an acid in water, so we are going to have Ka, acid dissociation constant. And like we say in the chemical equilibrium, is product of concentration of the products over product of concentration of the reactants. So in this case, what are you going to have? Remember, square bracket represents concentration. So that's what we have. Over what? Over the reactants. But like we said before, we don't put water. It has not undergone change. The change is very small, that it is insignificant. So what do we have here? We are going to have nitric acid as that. So this is the expression of the acid dissociation constant. Yeah, then the third equation is this one. Ammonia reacting with water. So let us have it. We are having our ammonia plus water. Now, in presence of water, ammonia is basic. So if it's a base, what does it mean? It means that water is the acid. Okay. So if that's the case, what happens? We apply Bronsted-Lowry here. And what does it say? It says an acid is a proton donor and the base is a proton acceptor. So this one being our acid, it will donate a proton here. When ammonia gets a proton, it becomes ammonium ion. It was neutral, so it's now positively charged. And when water lost a proton, it became what? It became an hydroxide ion. So that's the reaction. Next step is to represent the equilibrium constant. Now, because we are looking at a base in water, what we are having here is base dissociation constant Kb. Does it look like? It's the same as the way we do with chemical equilibrium. Product of the chemical products over product of the reactants. Square bracket representing the concentration. So we are having ammonium ion into hydroxide ion over ammonia, leaving out water because it almost remains unchanged. So that is what we have. And with that, I would like to say thank you. We urge you to subscribe, to react, to comment, to share, and also to remind you that this channel, PSSB, deals with physical sciences grade 12, 11, and 10. And natural sciences grade 8 and 9. Okay. We urge you that when you're using the channel, don't use the video. Use playlist. For grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. 10 and 11, just look for physical sciences grade 10 or physical sciences grade 11. For grade 12, every chapter is presented independently. Just look for any chapter of your interest and click the button. You'll have all the information you need. With that, I would like to say thank you. Stay blessed. Yeah, see you next time. Bye-bye.